Concrete is the dominant material used in construction, both in gross mass of material used, the energy consumed, and the pollution released from cement manufacture. There is a need for the construction industry to adopt sustainable and low carbon emission solutions in concrete production with an emphasis on resources management and conservation. Also, there is an effort by the construction industry to address the issues of environmental pollution caused by generated construction waste through the concept of reducing, recycling, and reusing. Next, the objective is to propose the workability, strength, and microstructure of high-strength sustainable concrete.
In this slide, I will be showing you the methodology of this sustainable concrete. First of all, for material that will be used that has been stated in the journal is first, Portland cement or PC, second, calcined clay, and then granite, river sand, and crushed clay brick waste (CCBA). The cement is of grade 42.5, conforming to IS 444/2003, turned into receipt from retail safe inside OTA town, Gun State at Nigeria. The recycled clay brick waste (CCBA) changed into domestically sourced as demolition waste from a constructing web page in OTA environs, Gun State at Nigeria. This pre-soaking method will assist to do away with a few added impurities and mortar. These homes had been decided following BS 812/1990 and BSEN 1097/1995. Meanwhile, the chemical composition of the Portland cement, tuba, sand, and calcined clay changed to ascertain the usage of the X-ray fluorescence XRF method, and the consequences are offered. The aggregates bodily homes suggest that the substance are according to ASTM C33/2000. For batching of concrete mix sample, a process of the batching proportioning of the concrete blend has been used. The first blend is referenced because the manipulated blend, which contains concrete produced with the traditional constituent substance to obtain the goal electricity of 40 megapascal after 28 days of curing, whilst the opposite mixes include beaten clay brick (CCBA) used to partly change the herbal sand at percentiles of 10, 20, 30, 40, and 50% mixed with the equal ratio of granite, water, and the superplasticizer as the within side the manipulated blend. The SC 363R 2010 mounted excessive electricity concrete HSC as excessive overall performance structural concrete with 40 megapascal and above compressive electricity. All mixed pattern combos have been cautiously combined collectively to make certain uniformity. Mixing turned into carried out following BS 1881/2009, whilst the workability of mixes turned into decided following BSEN 12350/2009. For sample preparation and testing, the metallic molds used for the concrete casting had been lubricated accurately with oil earlier than utilization to save you adhesion and make certain an easy remolding process. Concrete cubes of the size of 100mm cube had been used for the compression check, whilst the breakup tensile power of the concrete became evaluated in the use of cylindrical molds of 100 x 200mm size. The beam samples had been bolstered with a 4R8mm rebar with the availability of good enough cover. The samples had been then cured via way of means of entire immersion in a water curing tank at room temperature. The hardened samples had been examined after 7, 28, and 56 days of curing, and the comment had been recorded for every curing age. The microstructural evaluation became accomplished decided on samples from the examined hardened concrete. The usage of the Phenom Prox version of scanning electron microscopy (SEM) gear up with the strength dispersive X-ray (EDX). The SEM analysis had been carried at the floor of small portions of concrete samples without coating installed at the SEM breast tubs. The usage of the Phenom Prox kind SEM. They decided on samples encompass the managed samples and samples containing 10% and 50% CCBA. All samples training and checking out had been on the Fabric Laboratory of the Department of Civil Engineering, Covenant University, OTA, Gusted at Nigeria.
Based on the Journal 1, the method used in order for the determination of the workability, strength properties, and the optimum composition of the sustainable concrete mixes is SLUM test. This SLUM test is to determine the different relationship between the tensile strength and also the compressive strength. The study includes the development and testing all the concrete mixtures containing CCBA aggregate materials. This CCBA is known as the crushed clay brick waste. The material used in this study are Portland cement, calcined clay, granite, river sand, and also crushed clay brick waste. The first mix is referred as the control mix, which comprised of a concrete produced with the conventional constituent materials to achieve a target strength of 40 megapascal after 28 days of curing. The other mixes consist of crushed clay bricks, which is CCBA, is used to partially replace the natural sand at the percentage levels of 10%, 20, 30, 40, and 50% combined with the same ratio of granite, water, and the super plasticizer as in the control mix. So how does it conduct? First, the test conducted by the sample were appropriately labeled to aid identification, then cover it with plastic sheet. This is to prevent loss of moisture and will demolded after 24 hours after casting. Then the samples were then cured by complete immersion in a water curing tank at room temperature. The harder sample were then tested after 7, 28, and 50 days curing, and the average were recorded for each curing age. The result obtained is compressive strength, splitting tensile strength, and also the flexural strength. This is all the findings obtained in Journal 1. First is slump of various mix. This slump of the concrete mix range from 35mm to 75mm, indicate as the workability mix. It shows that the slump of the concrete mix indicate as moderate slump to low slump in a descending order, but based on the figure, overall the slump indicated as low. Next is compressive strength development with curing edges. The strength of the hardened concrete increased as the curing age increased. An increase in the CCBA content decreased the compressive strength of the concrete. The result then indicates that the highest strength is achieved at 56 days for a concrete mix with 10% CCBA and calcined clay, but the highest reduction in the compressive strength was noticed for a mix containing high content of CCBA, which is 50% at a comparable of 10% of calcined clay. Next is split strength at different curing edges. The utilization of CCBA as sand replacement decreased the tensile strength of concrete as the CCBA is increases. This result shows that 10% replacement of the sand with CCBA coupled with 10% of calcined clay. The strength is then improved by 8% after 28 days of curing. Next is the correlation of split tensile and compressive strength. The tensile strength increases with increasing curing age. As shown in the figure, the comparative trend of the relationship between the compressive and the split tensile strength of the concrete indicate as a good linear correlation between both magnitudes. For the flexural strength at different curing edges, the flexural test results on the beam indicate the behavior of the control reinforced concrete beams compared to the beam with CCBA aggregate used. Increasing the CCBA aggregate content decreased the concrete beam's flexural capacity except at the sand replacement level of 10%. The effect of this calcined clay as the mixture was noticed not to be significant, especially at the higher CCBA content. Last but not least is the correlation of flexural and compressive strength. This correlation between the compressive and flexural tensile strength of the concrete indicate as a close linear correlation between both magnitudes. Based on the Journal 2, the method used in order for the determination of fresh and hardened properties of the sustainable concrete mixes is the splitting test. This splitting test is to determine the different relationship between the tensile strength and also the compressive strength. The study includes the development and testing of the 7 SCC mix and 1 control mix, whereas this control mix contains 100% of Portland cement as the cementitious materials without any materials, but 8% of the control mix content was replaced with a different combination of pozzolana. This is for in each of the remaining 7 concrete mixes. So how does it conduct? First, this test conducted by the control mix design was normally vibrated after being mixed for 80 minutes. Then a total of 48 concrete samples were tested to obtain the compressive and splitting tensile strength, of which 32 cubes were tested for compressive strength development after 3, 7, and 28 days of moist curing. The remaining 16 cylinders were tested to determine the corresponding tensile strength of the concrete after 28 days of curing. High range water reducing admixture based on the polycarboxylic ether was used and kept constant at 1.5% for all the mix. So the result obtained in this journal is the workability and stability of sustainable SCC mix, compressive strength result, and also tensile strength result. This is all the findings obtained in Journal 2. First is workability result. All mixes shows a very good resistance to the segregation as indicated by VSI of 0 or 1, except for GM3, which exhibited as a VSI of 3. The poor stability of GM3 may be attributed to the 60% slags, which was the largest amount of concrete mixes. Next is compressive strength development after 3, 7, and 28 days of curing. All mixes produce lower strength compared to the control mix at all ages. GM4 performed the best of all mixes in terms of 28 days, as it reached the strength of the control mix after 28 days of curing. The compressive strength development after 28 days of curing. All mixes produce lower strength compared to the control mix at all ages. The highest cement replacement ratio of 80%, the 28-day cube compressive strength shown is suitable for many applications. The GM4 performed the best of all mixes in terms of 28 days as it reached the strength of the control mix after 28 days of curing. For the tensile strength after 28 days of curing, the 2 cylinders were tested for splitting tensile strength for each of the 9 sustainable SCC mix, in addition to the control mix and the average values.
For comparing between Journal 1 and Journal 2, for slump tests, the result obtained is compressive strength, splitting tensile strength, and flexural strength. While for Journal 2, which is splitting tensile strength, the result obtained is workability and stability of sustainable SCC mixes, compressive strength results, and tensile strength results. For strength and benefits, for Journal 1, addition of calcined clay to partially replace cement in the concrete mix help enhance the compressive strength properties compared with the control mix. While for Journal 2, cement was partially replaced with 80% of minerals including fly ash, silica fume, and slag. The weakness for Journal 1 is it is a very high cost, which is it uses scanning electron microscopy. While for Journal 2, the weakness is it is a very complicated process. It took a very long time to complete as the test required 7 SCC mix and 1 control mix to obtain the result. In conclusion, Journal 1 demonstrated that crushed clay brick aggregate CCBA can be effectively used to partially substitute the natural sand in the production of moderate high strength of the sustainable concrete. It also stated that by replacing the natural sand with the CCBA in the concrete mix, it is able to reduce the workability of the mix. However, the addition of calcined clay to partially replace cement in the concrete mix helped to enhance the compressive strength properties. In Journal 2, it proved that the 80% of the cement replaced with various combinations of fly ash, silica fume, and slag helped to produce the best result in terms of compressive strength development after 3, 7, and 38 days of curing. However, these sustainable mixes containing 10% to 20% of silica fume showed the higher resistance to segregation compared to 60% slag and showed excellent segregation resistance if it is included with 15 and 55% slag and 15 silica fume. Overall, it can be concluded that the objective can be set as achieved as the mixes in which cement was partially replaced with admixtures are successfully obtained the best result for the workability, strength and microstructure of high-strength sustainable concrete in both of the general.
Next is recommendation. It is recommended to use the 56-day strength as the rapid hardening of slag and fly ash cement continued beyond the standard 28 days. Okay, that's all from us. Thank you for watching.